All right. Chapter 4. Chapter 4 will be fun. I enjoyed making this chapter. I'm going to enjoy teaching it. Hopefully you enjoy learning it. But this is about triangle congruency and proving that two triangles are congruent. So if we have this triangle and the exact same triangle like this, we can't just say they're congruent. We have to prove that they're congruent through that thing we learned in chapter 2 with the statement reason. But with that being said, before we can move on to that, I have to teach you a couple more rules for your statement reason tables, specifically for these triangles. So starting with the triangle sum theorem. And this is you already know what this is. The triangle sum theorem says that all of the angles inside of a triangle, all the interior angles, sum to 180 degrees or pi radian. The other part of the triangle sum theorem says that the outside angle of any triangle, so I'll give you a diagram for this one. This outside angle right here, that measure is equal to the sum of the two opposite angles. So that would be this angle plus this angle equals that angle up there. It's kind of complicated to explain, but it makes sense once you look at it. So if we choose any other triangle for this, make a right triangle here. If we want to find this right here, it would be 90 degrees. This angle plus this angle equals this huge angle out here, that giant obtuse angle. Okay, this is another stupid one, like the reflexive property, but the right triangle, or the right angle congruence theorem says that all 90-degree angles are equal to all other 90-degree angles, which, I mean, that's going to be really useful, but you can't just say 90 is congruent to 90 without having a reason to, so the right angle congruence theorem, all 90 degrees are congruent to all other 90 degrees. The isosceles triangle theorem. Again, you already know this one. If any two sides of a triangle are congruent, then their base angles are going to be congruent. Right, so that's just an isosceles triangle. So, I mean, if we have here an isosceles triangle, and we say that these sides are congruent, that's also going to mean that these angles are congruent as well. Which, I mean, just really what an isosceles triangle is, but okay, from there, a bisector definition. This one is one that is kind of important. So if we have a line segment here, like this, and we'll say this is the midpoint, right? So if we have A, B, and C, and B is the midpoint of AC, then if we have a line that runs through B, we would say that B is the bisector of AC because it touches the midpoint. It cuts it into two equal parts. That one will be pretty important throughout the rest of this course. The median. So if we have a triangle here, and we say the midpoint of the hypotenuse is right there. Let's label this A, B, C. the midpoint of AC is right there. So if we have a line coming out of B, let's say it's a ray, and it hits the midpoint, that line there coming out of an angle and bisecting AC is called a median line. And I mean, it doesn't have to keep going. It could just stop here and be a segment. It could be a full line like that. Doesn't matter. That line would still be called a median. That one will be important, and a mid-segment. This one will be important for chapter 5 or 6, I believe. If we have a triangle here, call this one A, B, and C again. And this is the midpoint of CB, this is the midpoint of AB, and this is the midpoint of AC. If we have a line that comes from the midpoint to the other midpoint like that, well, that's going to be called the mid-segment if it connects two midpoints. Give you a sneak peek of, I think it's chapter 6. We're going to be dealing with this. All these mid-segments make the mid-segment triangle. And then these would be parallel. These would be parallel. And these would be parallel. And then congruent. But I digress. We'll get to that later. But all you need to know is that those are mid-segments that connect two midpoints. Okay. I think that's all I have for you there. Okay. So now that we know those, and I'd go back and write all that stuff down because that'll be important. Chapter 4, proofs. So when proving, there's going to be 5 ways to prove that two triangles are congruent. You're going to be able to prove through number 1, side, and inside, side. You have to prove that all 3 sides of the triangle are congruent. Sorry, I should flip these like that. So this is just the triangle, but it's been rotated 90 degrees. So you have to prove that all 3 of these sides are congruent. Again, I would write this stuff down. Next, you can prove it with side, angle, side. Side, angle, side. Not to be confused with side, angle, side, or an angle, side, angle. But like this, side, angle, side is specifically when you can prove that this side is congruent and this side is congruent, and this angle here is congruent, like that. So if you know that this angle is congruent, this angle is congruent, and then 2 sides. So 2 sides with the angle in between, you know, is congruent, would be side, angle, side. So in the label, the angle's between the 2 sides. In here, the angle has to be between the 2 sides. All right, next is going to be angle, side, angle. Angle, side, angle. And for angle, side, angle, it's just like side, angle, side, but we have to have, that's kind of messed up. Those don't look alike, but you have to have an angle here that you know. So we'll say that these angles are congruent, and we know that these angles here are congruent. Then we would have to know that the side between them is also congruent. So again, the side is between the angles here, so the side is between the angles here. From there, we have angle side. Angle side. And this is when, just doing an obtuse triangle, this is when you can prove any two angles you want are congruent, and then any side that is not between them, because if the side were between them, then you would have side angle side. So let's say we can prove that congruent. And that would be angle side. So any two angles and a side that's not between them. And then hypotenuse leg. Hypotenuse leg is probably, as you guessed, if you have two right triangles like this, and you can prove the hypotenuse is congruent, and any leg is congruent like that, then you have hypotenuse leg. And you still have three pieces of information because these right angles are also congruent, but because of the right angle congruency theorem, you don't have to write that out. Okay, I apologize for that cut there. I don't know if the room is darker now. It's pretty late, 10:25, and if this is causing a glare, I tried to fiddle around with it. Hopefully it's working now. Well, we just went over these triangle congruency theorems, and again, I would write this down in whatever way makes sense to you, because this stuff is going to be pretty important. You're going to have to memorize SSS, SAS, ASA, AAS, and HL. And with that, we're going to get into some examples here, using what we learned in Chapter 2 to prove triangles are congruent using these congruency proofs here. So give me just a second to erase all this. Okay. And we're going to start here with a parallelogram. Like this. All right. And we're going to be given that, well, first I should probably label it A, B, C, and D, like that. And we're given that AB, given up here, we're given that line AB is parallel to line CD, parallel to line CD like that, which just makes this a parallelogram. I apologize, I drew this incorrectly. There's supposed to be another line cutting it right here between A and C. We're also told that AB is congruent to CD. It's congruent to CD. Really just telling us that this is a parallelogram, and we want to prove the triangle ABC is congruent to triangle CDA. So triangle ABC is congruent to triangle CDA. So this right here is congruent to this right here, right? And so first, I want to write out what we have here on our diagram. So first we know that this and this are going to be parallel. And we also know that this and this are going to be congruent with each other. And from there, we want to prove that these triangles are the exact same. So right here, I'll do our two-table graph like that with our statement and our reason. And with this, we're going to, if you want to try this on your own, you can, but I will also walk you through it. So first, I'm going to write out our givens, that A, B is parallel to C, D, and A, B is congruent to CD because it is given, right? And then from here, we can go about this several ways. But first, I'm going to look at this. And remember that stupid rule I told you about, the reflexive property, where side AC is congruent to side AC? Well, right here, we can do that again, saying AC is congruent to AC. Is congruent to AC, like that. So now we have two sides reflexive. Now we have two sides, and we just need to find an angle or the third side. So there's no way to find the third side, but we can find an angle. And if we know that these are parallel, let me get a different color. Let's take a light blue. And if we extend these out like this, here, we know that these are going to be parallel, and this is going to intersect them if we draw it out like that. So we have what we talked about in the previous chapter, right? We have the two parallel lines cut by a transversal like this. And with this, we can now find angles because of those angle relationships I told you about. So we can find here that, we can do anything, but let's do the alternate interior angles. Well, alternate interior, let's choose this angle here to work with. And from here, on the same or on opposite sides and inside would be this angle here. So we know that these two are going to be congruent because alternate interior are always congruent. So just like that, let me erase all this extra stuff here that I have drawn out. Just like that, we know that those angles are congruent, so we can write that out. Angle, let me fix these letters here that got drawn over, like that. So we know that angle A or BAC, so angle BAC is congruent to angle DCA. And that is because of alternate interior angles. I'm just going to write AIA. For a test or something, you should write alternate interior angles. And like that, we have side, angle, side, side, angle, side. So we can say that triangle A, B, C is congruent to triangle C, D, A, triangle, sorry, because of side, angle, side. Just like that. And that's how you prove these two triangles are alike. So give me a second to reset the board, and I'll give you another example to try. I think we have 4 examples to try out, and they should get more difficult as we go. So here we're going to have triangle looks like this, and we have a line cutting them right here. And we are told, let's write our givens. We are told that D is the midpoint of AC. D is midpoint of AC, like that. And we are told that, I have a note up, I have the letter up here, it looks like it's in the given. I apologize. We're also told that BA is congruent to BC. BA is congruent to BC. And we are trying to prove that triangle ABC is congruent to triangle CBD. CBD like that, and I have to label this up here. B, A, C, D. So that's our triangle, and I'm going to write out right here our table for this, our statement, and reason. So first, I want to label our givens on this triangle. So first we know that D is the midpoint of AC. So that means that AD and DC are going to be congruent because it cuts it perfectly in half. Second, we know that BA and BC are congruent. So this and this are congruent. So already we're given 2 of our 3 pieces of information here. And let's write this out on our table. So we know D is midpoint of AC, and that BA is congruent to BC because it is given. So already we have 2 pieces of information. And again, I told you this reflexive property was going to be really important. And we're going to see it again with BD being congruent to BD on both of these triangles. It's going to be the back of both triangles, and they're going to be congruent. So we know that is congruent like that. So we can say that BD is congruent to BD because of the reflexive property. because it's the reflexive property. And from there, now we have side, side, side. So we have three sides that we know are congruent, and that's going to be side, side, side congruency. So we can already say triangle A, B, C is congruent to triangle C, B, D. Kind of ran out of space there. Because of side, side, SSS. And I mean, you can just write SSS, SAS, AAS, whatever, when doing these, because that's their technical term, is just the three letters, or two for HL. But there you go. That's how you would prove that these two triangles are congruent. Okay, so let me erase this, give you your next example. See if you can do this next one on your own. Get out a piece of paper or something. Okay, we're going to have diagram looks like this. And it goes A, B, C, D. A, B, C, D, E, like that. And we're trying to prove, well, first we're given that angle BAE, angle BAE is congruent to angle AED. And again, when labeling angles, make sure to use the 3 points so it's more specific than just angle E, angle A. We are also told that AE bisects BD. So we know that AE bisects BD. So we are trying to prove that triangle ABC is congruent to CBE. Proving that triangle ABC is congruent to CBD, CDE. CBD was the last one. So we're told this, and we're trying to prove triangle ABC is congruent to triangle CBD or CDE. So pause, see if you can do this one on your own, trying to prove that this triangle here is congruent to this triangle here, both halves. So try that one. Okay. I'm going to write our table out here with statement and reason, like that. And again, we're going to start with our givens. So angle BAE is congruent to AED, because and that AE bisects BD. Like that. And this is because given, we're told that. And again, I like to write this out on the diagram. So angle BAE is congruent to AED. So BAE, so this right here, is congruent to AED. AED, so right here, like that. So those angles are congruent. We're also told that AE bisects BD. So AE right here bisects BD, which means that this and this is going to be congruent. Okay, so from there, we can take out, one more angle from this. If you want to try to figure out which angle it is, go ahead. All right, so remember on chapter 3 when I was telling you about that weird angle that's hard to describe, but you can always see it. And that was the vertical angle. And right here, these would be vertical angles. ACB and BCD are going to be vertical because they touch each other right at their point. They share the same point of the angle, if you will. So we know that this right here is going to be congruent to this right here. So we know that angle BCA is congruent to angle ACD, or ECD, I apologize, ECD, because vertical angles, like that. And now we have two angles and a side that isn't between them. So if you remember what this is, it's angle, angle, side, AAS. And same thing over here, angle, angle, side. So this is like you took one triangle and you flipped it 360 degrees and then mirrored it, right? So we know, so now we can prove that triangle ABC is congruent to triangle CDE because of angle, angle, side, AAS. AAS congruency. So that's how you would prove that these two triangles are congruent. And I think I have, oh no, I have 3 more examples for you. You got quite a few examples for this chapter, but this chapter is going to be really important. I can imagine that in a geometry class you would spend, a month and a half, 2 months on this topic alone. Well, not just this topic, but the proving things with this stuff. It's good practice with the 2-table charts and with the, proving triangle congruency and whatnot. Okay, so we know now we're going to have this diagram here. So this is our diagram like this. Okay, and then it goes A, B, C, D. So kind of like actually exactly like the one before, but you're going to get different givens for this. And the givens are going to be we're going to be told that BD is perpendicular to AC. So we know that BD is perpendicular to AC, like that. We're going to be told that BC bisects angle ABC. So BC bisects angle ABC. Yep. Like that. There's point 1, point 2. We get one more. Nope. Now we get to prove triangle ABC is congruent to triangle CBD. CBD. Like that. So again, try to pause here, figure it out yourself. Now I will go through it. Like this. Okay. Again, we have our statement and reason, like that. And again, we're going to start with our givens. So BD is perpendicular to AC, and that BC bisects ABC. Sorry, I ran out of room. I don't know if you can see that from back there, but given. Okay, so we have this. Now, I also want to write this up here. So first, starting with the perpendicular. Well, if something is perpendicular, that means it crosses at a perfect 90-degree angle. So if this is perpendicular to this, that means that this is 90 and that's 90. So we're dealing with two right triangles here. We also know that BC bisects ABC. So that means that this angle and this angle are going to be congruent as well. So we already have, again, two pieces of information off of this. We just have to find one more. And if you've been paying attention to that one stupid rule that's come up, this will be the third time, it's going to be the reflexive property. And the reflexive property is kind of like the, corresponding parts of congruent triangles are congruent. It's kind of like that, where it says that BD is congruent to BD, so I know that these are going to be congruent to each other, and I can write down BD is congruent to BD because of the reflexive. The reflexive property. And now we have our three things we need. We have two angles and a side. But the reason this is an angle-angle side is because the side is between our two angles. So we have angle, side, angle. And we can say that triangle ABC is congruent to triangle CBD because of angle, side, angle, angle, side, angle, like that. And we've proved it again. Now we move to some tricky ones here. So, and give me just a second to erase all of this work here. Like that. And our diagram for this one looks a bit different. Actually, let me, I'll just move. Looks like this. Actually, I apologize. I drew it a bit incorrectly. I just have to fix this part right here. It's going to look like this and like this. They're going to have to cross right there. And then I have this labeled A, B, C, D, E. So it goes around like that. A, B, C, D, and E. So this is our diagram. Has this overlap area here. Creates 1, 2, 3, 4, 5 different triangles. And we are given that angle ABC is, so angle ABC is right angle is 1, and then AC is congruent to BD. We're also told that AC is congruent to BD. Like that. And we are trying to prove that ABC, DCB, A, B, C, DCB, 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 like that. So when you look, you're trying to prove that A, B, C, and D, C, B, so these two triangles that overlap each other are congruent. So what I like to do here is pull these two triangles apart so that we can see what we're working with. So we would have, let me do that a bit better. No, too big. I apologize. Give me a second. Work this out here. So if I can't draw triangles, right? How can I teach this? Okay. So we're trying to prove that these two triangles, A, B, C, and then B, C, D, are congruent. And then this would be, right here would be point E. Like that. So those are the two triangles we're trying to prove congruent, just pulled apart. And I mean, that may not help you, but it helps me to pull them apart when they're overlapped like that. And then right here, I'll draw our table chart thing, two column proof, statement, and reason, like that. So first, again, I'm going to write out our givens. So angle A, B, C is right. And AC is congruent to BD. Is congruent to BD, like that. And this is because it is given. And I don't know if I'm standing in front of it when I write over it like that, but we'll see. And I also like to mark it on our diagram. So I'll put it on both diagrams in case you like to pull it apart or keep it together. So ABC is right. So ABC, right there is a right degree. And that's it. And then we would also put it right here. ABC is right. And AC is congruent to BD. So AC is congruent to BD. So this and this are congruent. So is that it? That's all the information we're given. Okay, yep. No, I left something out and I apologize. We have one more given. I was going to say, we're also told, let me write this down here, that angle BCD is right. I apologize. I don't know if you can hear that cat down there wanting to get in. So angle BCD is right. And we'll put that here too. BCD is right. That's all because given. So I'll write that up here too, like that. And now all we have to find is one more piece of information because we have the hypotenuse, the right angle. So we just have to find one more piece of information. And when dealing with a right triangle, I mean, hypotenuse leg is really the only one that deals with right triangles. So I'm telling you right now that's what we're going to use. So that means we have to prove that one of these are going to be congruent. One of these sides are congruent. I apologize for that. I don't know how distracting it is on the camera. But let's look here. And one more time, your best friend, the reflexive property, is going to come in handy because we have BC is congruent to BC. And again, here you can see on both of these little diagrams, BC is on both triangles. So we can say that BC is congruent to BC. This marker's running out of ink. I may have to get a new one. And this is because, again, reflexive. And I didn't put so many reflexive in here because I like the reflexive property so much. Although I do, so did these online curriculums that, like online practice pages full of these problems. Almost all of them use the reflexive property, so I just copied down a couple. But now we can write that out on our diagram too, that these are congruent, so we know that this and this is going to be congruent with each other. And now we have the hypotenuse, or the hypotenuse and the leg of each hypotenuse and the leg. So we can say that triangle ABC is congruent to triangle DCB. Like that because of hypotenuse leg congruency. And with that, that is our final example. I was wrong. I had it split up on my notes page, and I thought it was two different problems at quick glance. So that's it. You got to save one more problem. And with that, the next chapter you should probably break up. It's triangle relationships, like the anatomy of triangles, not just proving that they are congruent. That one took a couple of days for me to learn, but with that, I will. You can head to the chapter 5.